Draw a unit circle and estimate the places where sine theta equals 1/2. Draw a triangle for this. So, and then what we're going to do is use this to solve sine theta equals 1/2. So we'll draw a unit circle. Remember, a unit circle has a radius of 1. Now, on our unit circle, what is sine of theta? Sine of theta is y. So this equation that says sine of theta equals 1/2 is really the same thing as saying y equals 1/2. If this is a unit circle, here's 1, and this is 1, and over here, this would end up being -1 and -1. So if we say y equals 1/2, here's about y equals 1/2, and we have a line that goes across. How many answers are there? You can see in the picture that there are 2 answers here. And we need to know both of those answers. Now my picture may not be perfect, and that's okay. So now we're going to do this. If you can recall back to a couple things. We could either use our unit circle, or what we could do is think in this picture here, if I draw this down, and I say here's theta, sine is opposite over hypotenuse. Now, actually, since I labeled this as a 1, let me come over here and I'll draw a different triangle. And I'll call this theta. And here it is 1 over 2. And so the hypotenuse is 2. And we know we could use this Pythagorean theorem, and you should recognize these numbers. This will be square root of 3. What is theta? This is a triangle we've already worked with, and we should know theta is 30 degrees. Remember, the side opposite the smaller piece, the smaller leg, is the 30, and the opposite, the square root of 3, is opposite the 60 degrees. So that means that I didn't actually tell you if we're in degrees or radians, so let's just deal with degrees here. This will be 30 degrees, but we can see that there's another solution. What's that other solution? Well, if we compare these 2 triangles, they both have a radius of 1. They have the same height here of 1/2. And they are right triangles. So by hypotenuse leg of a right triangle, these 2 triangles are congruent. And this is also going to be theta. Or in other words, this is going to be 30 degrees. So when we measure our angle starting from the positive x-axis and we come around, what is that angle going to be? Well, that's going to be, the whole line is 180 and this is 30, so that will be 150. And since I didn't put any restriction on this, we have to say plus 360 degrees n plus 360 degrees n, where n is an integer. All right, let's look at the next one. I drew the circle for us. Let's label these values here. We know that we're starting with 0. Half the circle is pi. The whole circle, this coterminal, is 2 pi. Remember, 0 and 2 pi are not the same angle. They're just coterminal. This would be pi over 2, and this would be 3 pi over 2. Now, one of the things we need to know is the approximation of all these numbers. And we've gone over some of this. This is 3.14, and you know that. And take that number and divide it by 2. We get 1.57. And 3 pi over 2 is the same as pi plus pi over 2. So if we take these 2 and add them together, we get approximately 4.71. So now let's mark 1, 2, 3, 4. We should be able to do that regardless of having these values. What is this? What's the angle measurement here? These are radians. So we're marking 1 radian, 2 radian, 3 radian, 4 radians. Remember, 1 radian is the radius mapped out onto the circle. So about here is 1. And we go another piece here. And we'll have 2. And we come down here and we'll have 3. And just to see that a little bit better, let me erase the pi part. and I'll move it to here to say pi is approximately equal there. All right, now what we want to do is figure out what is the size of cosine 1, cosine 2, cosine 3, cosine 4. How big are they? What are those numbers? We're not going to take out a calculator at all, so we need to estimate it just based on this picture. What is cosine of theta on our unit circle? That's our x value. So really what we're doing is, for these numbers here, what is the x value? So, or these angles. So I'm going to come down here and I'm going to draw. Oh, I didn't write 4. So 4 would be somewhere around there. So what can you say about the cosine of 1? Well, we're looking at our xy axes here. This is a positive value. What can you say about the cosine of 2? Well, that's going to be a negative value, and so is the cosine of 4 and the cosine of 3. Now, let's make sure to see that if I place these on the proper spot, if this is pi over 2 is about 1.57, then this angle would be 2 minus 1.57, or approximately 0.43. Whereas if I came over here, that piece would be about 0.71. So the 4 angle is farther to the left. It's closer to the pi value. And we know 3 is going to be pretty close to the end of the circle here. So what is the smallest value? Well, we're going to look what's the smallest negative. That would end up occurring right there at cosine of 3. And then the next biggest would be cosine of 4, cosine of 2, cosine of 1. If we were going to estimate this number here is going to probably be, if we have negative 1, again thinking on a unit circle, and the coordinates at this point would be negative 1 comma 0. So the x value is negative 1. This is going to be somewhere close to negative 0.9-ish. And then over here, probably about negative 0.7, negative 0.8. In this piece, maybe about negative 1/2. And over here, somewhere around positive 1/2. So you can see they're getting bigger as we go to the right. On this next set of problems, what I want you to do is always draw the unit circle. You're always going to justify it and show exactly what these values are. So we'll start cosine of 50. So I'm going to come up here. Here's about 45. I'll go a little bit more than there. There's 50 degrees. 305, what quadrant would that be in? Remember, here's first, second, third, fourth. 90, 180, 270. So I'm going to be past 270. Maybe somewhere around here at 305. Now we can measure this in a couple of ways. We could look and see what is this angle here. That's 50. What is it going to 305? That would be 55 because of 360 minus 305. So the 305 is farther to the left, and we're dealing with cosine again. So cosine is the x value. And in this case, cosine of 50 is greater than cosine of 305 because it's to the right. That x value is bigger than this x value. Let's take a look at the next one. Cosine of 30, cosine of 40. Well, we don't even need to mark those angles. We can see here that's getting closer to that top. So which one's bigger? Cosine of 30. You can't just look to see what the numbers are. It could be that the quote-unquote smaller number is bigger. It could be for the cosine or sine, and it could be that the bigger number in terms of the actual angle. So you need to actually map it onto the circle and see what's happening. Cosine of 100 or sine of 100, sine of 101. 100 is going to be in the second quadrant. We have something like this, and then 101 is something after it. Now I put that a little exaggerated just to make it clear what's going on with it. So when I'm looking at this, what is sine on our unit circle? Sine is our y value. So I want to see what's the y value here. So let me go over to the y-axis. Which one has a bigger y value? Well, the one that's higher up. So which one is higher up here? It is 100. So the sine of 100 is greater than the sine of 101. Let's take a look at the next one. We have 80 degrees, and we have 290 degrees. So over here, 270, something like this. What is the sine is the y value, so we come over to our y-axis. And this one should be pretty easy because the sine of 80 is positive, but the sine of 290 is negative. So the sine of 80 is greater. What if I asked the cosine? Cosine of 290 is to the right of cosine of 80, so the cosine of 290 would be bigger. We could take a moment here and also come back to number 2. What if I was asking you to put from least to greatest sine of 1, sine of 2, sine of 3, sine of 4? Instead of looking at the x values, the sine are the y values, so you would look and see how close is each one to the y-axis, or where do they hit along the y-axis. And that's it for this lesson.